Hello, this is really a very difficult problem here. So we have to find number of real roots, and I've given this problem in the test 2 also, not given you full solution there, but a hint, right? So here I'm separately giving you the solution of this problem. Now the question here is, the graph of quadratic function f of x equals to ax squared plus bx plus 1 pass through point 1, 2. For what values of a does the graph intersect the x-axis at two distinct points? Now basically we are trying to say that the graph should intersect at two distinct points. That means there are two roots, and that also means that the discriminant part b squared minus 4ac should be greater than 0, correct? So those are the two things which we have to consider. Now this equation has got two variables also, a and b. So but we are interested only in finding the values of a. So we need to eliminate b. That's also a part of this question. How to eliminate b? From the given information that the graph of quadratic function pass through point 1, 2. So we can use this point x value as 1 and y as 2 and then get something relating a and b and eliminate b. Okay, so let's do that first. Okay, so what we're trying to do now here is that we're trying to find f of 1. F of 1 equals to, we're letting x as 1, so we get a plus b plus 1, right? And f of 1 is 2, so we'll write this equals to 2, correct? Now from here we can write what b is. So we got b equals to 2 minus 1 minus a, which means b is equal to 1 minus a, correct? So that point helps us to get an equation in terms of a. Now we will rewrite our equation in terms of a, and then we'll say f of x is equals to ax squared plus, instead of b I'm writing 1 minus a now, okay, x plus 1. Now it becomes simpler, at least we have one variable, right? For what values of a does the graph intersect x-axis at two distinct points? Correct. So now what we need to do? We need to find b squared minus 4ac, the discriminant, right? Which is b squared minus 4ac, correct? And since we want two distinct points, it should be greater than 0. So that is what we're trying to find now. Correct. So let's start doing that part. So let's now pick up this equation from here and see what is a discriminant, right? So we say d is equals to b squared. So what is b? B is 1 minus a for us, right? So we say 1 minus a, b squared, minus 4 times, and what is a? A is a, right? A, and c is 1 for us, okay? So that is b squared minus 4ac. Now this should be greater than 0, but let's first simplify this. It seems to be a very complicated thing for us, so let's expand it. So we get 1 minus 2 times a. You remember 1 minus a whole square is 1 square minus 2 times 1a plus a square. Okay, let me write a first. Plus a square, and this one is minus 4a, correct? So we can rewrite this as, rearrange a square we'll write first, and minus 4a and minus 2a gives me minus 6a, and here we have plus 1. So this is my equation, and this should be, discriminant should be greater than 0 if I want two distinct roots. Is that okay? Now, to find what values will give greater than 0, we can do quadratic formula, or we can do completing the squares, correct? So what do you want? Well, we can't factor it because just 1, and 1 times 1 is 1, we can't get 6, right? So that option is not there at all. So okay, let's do whatever quadratic formula you want to do. So let's find quadratic formula and find the value for a, right? So a equals to minus b, which is minus of 6 plus 6, that means plus or minus square root of b squared, which is minus 6 whole square, which is 36, minus 4 times ac, so 4 times 1 times 1 equals to 4, divided by 2 times a, which is just 2. Is it okay? Now this can be written as plus 6, no need to write plus in any case, I've just wrote it. Now 32, correct, over 2, right? And this is equal to, I can divide this by 2 and I get 3 plus minus, and 32 can be written as 16 times 2, correct? So 16 is a perfect square of 4, so I'll bring 4 outside and then divide by 2, which will give me 2, right? Square root of 2. Well, I did too many steps here. Anyway, let me just simplify this here for you. So what I'm doing with the radical sign is, so first let me write this again. I'm writing 6 plus minus. This is like radical is 16 times 2, okay? And then divide by 2. Is it okay? This is this equation. And then what I did was I brought 4 outside. So I did 6 plus minus 4, right, times square root 2 divided by 2, right? And then the third step what I did was I divided 6 by 2, got 3, and 4 by 2 got 2. So 3 plus minus 2, and that's how I got this back. Do you understand? So I kind of missed those steps. I think it's important to explain them. So A could be this, right? Now the condition is that this should be greater than 0, right? Now we'll see that part also soon. But let's see if we have to do this by completing the squares, how we'll do it. It's kind of a review for completing the squares also. I think it's an important issue. And let me do that part in blue because I already have 2 colors here on the left side, right? So avoid confusion. So what we are trying to do, we have a square minus 6a plus. So our determinant D is equal to a square minus 6a plus 1. And we want that to be greater than 0. We want this to be greater than 0 because we want 2 distinct points, okay? So let's do completing the squares. Fortunately, we don't have anything to factor from a square. Leading coefficient is 1. So we'll do half of this and say a square minus 6a. Half of this 6 is 3. So plus 3 square minus 3 square plus 1 greater than 0, correct? So this becomes a perfect square. So we can write this as a minus 3. Minus comes from there and 3 from there. Square minus 9 plus 1 should be greater than 0. And this is a minus 3 whole square. And we get this as minus 3 and 1 is minus 8, right? So I can take minus 8 on that side, correct? Or should I keep it here? Let me take on that side minus 8, okay? So it becomes plus 8. Minus 8 becomes plus 8 equals to 8. And then I do square root, right? Now important thing here is when you do square root, you get a negative term and a positive term, correct? Now, so here also that problem is there. We get a negative term and a positive term. And now when you multiply by negative terms, the sign should change. Okay? So that's the kind of critical thing which I was avoiding for the time being, okay? But I think, let me explain you in one more way. Well, because there are too many things to explain, so we'll come back to all together. We can see this as a vertex form, right? So we'll first draw a graph. Now here we have got x minus 3 whole square minus 8, right? Is it okay? So let me write right here. So this equation can be written as a minus 3 whole square minus 8, correct? It means that the parabola opens up, right? And the vertex is at 3 minus 8, somewhere here, right? And it opens up, so kind of here. Does it make sense? This is kind of your parabola, correct? And we have got 2 zeros. The 0 is at 3 plus 2 square root 2. 2 square root 2 is more than 3. Do you understand? Square root 2 is 1.414, correct? That is why. So 2 times 1.414 is more than 3. So we get a negative number also. Is that okay? Now we can find what 2 square root 2 is. So, well, 2 square root is this, and times 2 is equals to 2 times 2 is 1.41, 2.8. Okay, so the parabola is kind of wrong. It is positive, 2.2. So it is basically, let me write this as 3 plus minus 2.82. Yeah, 1.4. So 2.82, okay, approximately. So both are positive. So, so I will not change my graph, but I'll change the axis. I like this method of working, changing the x's, right? Okay, so that's my graph now. Do you see? This becomes my y-axis and this becomes my x-axis. Do you see that? Correct? And this point is 3 minus 2.82, correct? 0.2 you can say, and that is 3 plus 2 square root. Do you understand? And this one is 3 minus 2 square root 2. Does it make sense? This is 3 minus. Okay, that's my parabola. Correct? So that's how the parabola is going to look. And if it's from the sketch, you know, when is it greater than 0? It's greater than 0 on this side. Do you see that? Those sides. Therefore, what is the solution? Solution of the equation. When will you have two distinct roots? We will have two distinct roots if a is less than 3 minus 2 square root 2, or if a is greater than 3 plus 2 square root 2. Do you get that idea? Correct? So this is how we can actually do it. So we got the x-intercepts, we got an idea of how to do it. We can solve from here also. Let me show you here. I don't want to stop it here. So we do square root both sides. So we'll do a minus 3 is, I'm not writing the sign here. There's a purpose for that. When we do square root, then we get square root of 8, but with plus and minus sign. Plus sign, and I should write minus sign like this. Correct? So basically we are doing negative of it. So what really happens is, if we use the plus sign, then I have to write my inequality as a minus 3 is greater than square root of 8. But if I use the minus sign, then I have to write a minus 3 is less than minus square root 8. That is what it is. And that is why I was stopping here and giving you so many other explanations. Do you understand? And what is square root 8? 2 square root 2. 8 can be written as 4 times 2, right? 8 can be written as 4 times 2. 4 is a perfect square of 2, so 2 will come out, right? Many students get confused with this kind of thing also. So let me show you that here. So 8 equals to square root of 4 times 2, right? So 4 is a perfect square, so it from the square root comes out, so you get 2 square root 2. This is what 8 is, correct? So instead of 8, I can write 2 square root 2. So from here, we say a is greater than 3 becomes plus, right? 3 plus 2 square root 2. Do you see the same answer? And from here, we get a is less than 3 minus 2 square root 2. This side. Do you get the idea? So this question involves thorough understanding of the topic, the whole chapter as a whole, right? So here we have concept of radicals, how to solve the radicals. We have concept of quadratic equations and quadratic functions, because from a point we have to eliminate all these things. Number of roots, right? Linear equation, because x-axis is a linear equation, and whenever we are trying to say that intersects x-axis, that means basically we are talking about linear and quadratic, both equations. So system of equations are involved here. Do you get the point? It's a very beautiful example. I'd like you to go through this video again, go slowly, stop at times, try to understand the concept and then move on. Well, if you appreciate it, do put your comments there and let me know. And if you want more problems like this, well, there's no dearth of it. You can get many. Enjoy, have fun.